All right, folks, in this video, we're going to start to look for specific patterns in sequences, and we're going to start to make a little bit more sense of them. Some of you will appreciate this video because I'm actually going to give you a formula. I completely realize on the days 2 and 3 videos, it might have been frustrating if you couldn't figure out the pattern right out the gate. But here it's going to kind of make more sense of the madness. So hopefully this helps you out quite a bit. Today we're going to focus on something called an arithmetic sequence. Arithmetic sequence is when you have a list of numbers and consecutive terms have a constant difference, meaning we're constantly adding or subtracting the same number each time. So the key word here is a common difference. So maybe I'm adding 7, maybe I'm subtracting 5, maybe I'm adding 4, something along those lines. We will not be multiplying or dividing term by term. We're only adding or subtracting. The common difference is going to be referred to as the variable d. And to figure that out, if you can't kind of intuitively just look at the list and get it, is just take one term, any term in the list, and subtract the one that came before it, and there's your common difference. So here I go 142, 146, 150, 154. Well, it looks like they're increasing, so my common difference should be positive, and they're increasing by 4, so my common difference is just 4. See, -5, -2, 1, 4, 7, they're increasing again, so I'm anticipating a common difference. And see, negatives might be challenging for some of you, so to go from 1 to 4 to 7 just increases by 3 each time. Let's see, 8, 3, -2, -7, -12. Okay, these are actually getting smaller. So they're decreasing. I'm losing value. That tells me I should anticipate a negative common difference. In this case, that would be a -5. So now let's look at sequences that maybe are, maybe aren't arithmetic. So the first one, 2, 4, 8, 16. Let's see, to go from 2 to 4 through addition or subtraction only, I'd be adding 2. 4 plus 2 is not 8. Okay, so that's not going to be arithmetic. This one we're actually multiplying term by term, which will be a different pattern we'll figure out later. 3, 6, 9, 12, 15. I can only use adding, subtracting, has to be the same thing each time. 3 plus 3 gives me 6, plus 3 is 9, plus 3 is 12. So that works out. My common difference here would be 3. 1, 5, 9, 13. Common difference there would be 4, 2, and a -6 for the last one. So now let's look at the formula. And I'm going to have the formula shown on each subsequent page, so kind of be patient for when that comes along. To figure out the explicit formula for an arithmetic sequence, here's what you're going to have. The nth term is going to be equal to whatever term you started at, plus n minus 1 times the common difference. And this kind of makes sense, right? If I wanted to figure out let's say the 10th term, I plug in 10 here, that means I would start at the first term and take 10 minus 1, that'd be 9 differences. So I'd basically take 9 steps to get to the 10th term. So that's where this formula comes from. Once we go through and plug things in, we'll distribute whatever our difference value is into parentheses and combine like terms just to clean things up, but that's not going to be too terribly difficult. All right, so let's get the formula here, and I've got it listed right here for you in case I scrolled too fast and you're too lazy to pause. So we have a common difference of 3, that's important. So our common difference is 3, that's the d value. And the first term is 2. So first term is a 1. So here's what the initial setup would look like. Now we'll distribute the 6 in there, and then we'll combine like terms, so a -6 and a +2. So 6n minus 4. That is my explicit formula. See another example, shall we? 5, 8, 11, 14, 17. All right, they didn't really tell me explicitly the first term, but I can infer. First term is 5. All right, cool, not too terrible. And what is the common difference, though? They don't tell me that, so I have to go back here and figure it out. Let's see, 5 to 8, 8 to 11, 11 to 14. It looks like we are increasing by 3. So I'll plug things in, clean it up, make it look nice. And then the part 2 of this is find the 35th term. So let me just plug in 35 for n, and I'd get 107. Not too terrible, right? All right, next up, we're going to have 2 different problems. I'm actually going to suggest you pause these because I'm not going to go kind of as in-depth as I did on the previous problems. So pause these if you need to write them down, and then I'll reveal the answers when you unpause. So for the first one, we have 6, 11, 16, 21. My first term is 6, and I'm increasing by 5. So I plug the information into this formula, again, cleaning it up. Then to find the 100th term, I just plug in 100 for n and simplify. Next up, my first term is 3, so 3 would be a sub 1. My difference, I'm going down, so it's negative. My difference would be a negative 3. After we distribute and add like terms, clean it up, we'd get negative 3n plus 6. Then the 46th term, just plug in 46 for n, I would get negative 132. But don't worry, some of you might be thinking, hey, this is way too easy. Don't worry, we can make it more complex. So here we have a sequence, but some things are missing. Bum, bum, bum. So first, I know my first term is 100. Then I drop down some, drop down some, drop down some more, and my fourth term is 82. Let's see. So I know my difference has to be negative, right? I'm losing value. I'm decreasing. So let me figure out what I know. I know my first term is 100, and I know my fourth term is 82. So the real winner out of this information is that the first term is 100. Well, I could use the fact that I know A4 is 82, and I can actually plug that in for A sub n. So I could say my fourth term is equal to my first term plus 3 steps, right? So to go from here to here, I take 1, 2, 3, and each step is equal to a difference. I don't know what that common difference is, but we're going to figure that out. So let's plug in what we do know. My fourth term is 82. My first term is 100. We can solve that to find d. D is negative 6. So I'm dropping negative 6 each time. So then we can go through and go back to our formula. Now that I know the first term, I know the common difference. I'll distribute that in. I guess I should have parentheses over here because it kind of looks like a minus 6. And then from there, we'll clean it up and make it look nice. This example is going to be the exact same, right? I know my first term, I know my fourth term. To get my fourth term, I'd start off at 80. And then I would add 3 common differences. I would take 3 steps to get there. If you're ever confused on what this little number should be, it's always going to be the difference between these 2 subscripts. 4 minus 1 is 3. And that actually holds true for our initial formula. N minus 1 is n minus 1. Holy smokes. All right, let's plug in what we know. Our common difference here is 15, and that makes sense that it's positive, right? We're increasing in value. So then plug in our first term and our common difference, combine like terms, make it look nice, and we get the explicit formula of a sub n equals 15n plus 65. And just to double check, we're not asked to find the rest of it. All right, cool. Neat, neat, neat. Oh, I guess it says what are the second and third terms? Whoops. Well, if my common difference was 15, let's see, that would be 95. And then this would be 95 plus 15, 110. Cool. All right. Now with words, I've got the fourth term of a sequence is 20, and the 13th is 65. So right out the gate, I'm noticing that I have no flippin' clue what my first term is, and that's kind of worrisome. All right, so fourth term is 20, 13th is 65. I want the explicit formula, and then I got to find the 30th term. This is a lot of work, holy crap. All right, let's take a look at what we know. Fourth term is 20, 13th is 65. Okay. Well, if I start at the fourth term and then take 9 steps, that would get me to the 13th term. So remember, I'm finding the difference between the 13th and fourth term. That's 9 steps. So now I can go through and kind of plug in what I know. Again, to get to the 13th step or 13th term, we start at the fourth term and then take 9 steps forward. And this allows me to find my common difference here is 5. All right. Well, now I can use that to figure out the first term. So to find the first term, I know that my fourth term was 4, and I can kind of work backwards, right? If each term going forward, I add 5, that means going backwards, I would just take away 5. So if my fourth term was 20, that means the term before that was 15, before that was 10, before that was 5. So my first term is 5. All right, so now I know my first term and I know my common difference, and I can plug all of that in here to that formula. So now I've got my explicit formula. Oh, cool. 5s knock each other out. Love when that happens. So my explicit formula is to find the nth term. It's equal to 5 times n. And then we were asked to find the 30th term. So I'm going to take 5 times 30. 30th term here would be 150. All right, let's take a look here. We have a stadium. Number of seats in the first 13 rows follow an arithmetic sequence. That means they increase by the same number as you go back, 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 back. Rows 1 and 2 are shown in the diagram. Looks like row 1 has 14 seats, row 2 has 16. So I'm already inferring that we're increasing by 2 each time. So we're probably going to add 1 seat to each side. All right, cool. How many seats are in row 13? So I'm basically trying to find what is a sub 13. Let's take a look at what we know. I start off, first term is 14. Common difference is 2. I can go to the formula right here, plug in what I know to get my explicit formula. In this case, it's 2n plus 12. Then we're asked how many seats are in row 13. So I want the 13th term. So I'll plug in 13 for n. I would get 38 seats. 2 times 13, 26, plus 12, boom, 38. Next step. After a knee surgery, your trainer tells you to return to your jogging program slowly. He suggests jogging for 12 minutes each day for the first week. Every week thereafter, increase by 6. So we'll go 12 minutes, and then 18 minutes, and then 24 minutes. How many weeks will it be before you're up to jogging a full 60 minutes? So how long will it take us to jog basically for an hour? That sounds like my personal nightmare. All right, let's take a look at what we know. First term is 12. We're increasing by 6. I can take those two ingredients, plug them into my formula. My explicit formula is now 6n plus 6. Now here's where we have to be paying attention to what the question is actually asking. It's not saying, what is this 60th week going to look like? It's saying, how long will it take us, during which week will we be jogging 60 minutes? So we're actually going to set this equal to 60 to figure out which term in the sequence is this, because that's going to be the week, right? If it's the 5th term, that would be the 5th week. Well, let's go through and solve this out with some straight up algebra. This is just solving a 2-step equation at this point. Subtract 6, divide by 6, and we would get 9 weeks. So on that 9th week, we are jogging 60 minutes. All right, folks, that's all I've got for you for arithmetic sequences. If nothing else, please make sure you've got this formula written down somewhere safe where you will not forget it, because it will come in handy. And you know the drill. If at any point you have questions, you gotta let me know. Good luck, have fun, be safe, roll tide.